Hi, my name is Stefan, and this is a recording of the presentation of test-driven development that I gave for the C++ Meetup in Vienna. In this presentation, I want to talk about, test-driven development, which is very close to my heart because when I learned it, and I'm practicing it now for several years, it was a very transformative process for me, and I do believe that I'm a much better developer when I apply test-driven development than if I would be without it. So why should we bother about test-driven development? Well, test-driven development is a means to an end. We are hired by a firm to produce software and to produce software constantly at a fast pace, or at least as fast as the circumstances allow us to move forward. And to do this, we need to be able to adapt the code, maintain the code easily, adapt it easily, and extend it easily. As a result, we need a high quality code. You can call that clean code or whatever, but it's important that the quality is high. But there's only one way how you can get high quality code, and that's by regular refactoring. That means you need regularly to clean up the code, make sure it's in order, that every structure seems about good, that you decoupled systems, you applied patterns when reasonable, so it's easy to extend, easy to maintain, and easy to fix if something is broken. However, refactoring comes with a caveat. In a lot of systems, and I'm sure you have similar experiences like I have, a lot of systems out there are legacy systems. Even if they're brand new legacy systems, but a lot of them are legacy systems which are all coupled, which are all spaghetti code, which are not modular, not testable, and it's a real pain to refactor those because you can't have the confidence that when you change something that it actually results in better code rather than worrying that you broke something. Because in most cases, when you have a legacy system, you refactor something and somewhere else something breaks due to coupling. And that's a big issue. So you need a way to make sure that you can be confident that you can refactor and have a high quality code. And you can do that by having an automated test suite. Having automated tests alone is not enough. You need to have a good test coverage. I mean, a real test coverage, not a fake one. You need to have meaningful tests, and you need to test all the different behaviors of your system. One thing that helped me to improve the design of my code and to have this confidence that I can refactor is by performing test-driven development. Here on a side note, I took this motivation from a presentation from Matt Parker. I don't want to take credit for something I didn't do, but I have to see a better motivation. For me personally, I totally subscribe to this logic. We want to have good tests so we can have high confidence that our refactoring will clean up the code and doesn't break anything, and that allows us to go fast. So where is TDD coming from? TDD is coming from extreme programming. And extreme programming is a practice originating end of 90s, early 2000s, if I'm not mistaken. And the idea behind it is that you want to do everything that is good for the quality of the code. If you implement new features, you have feature branches, and those feature branches get merged in at some point. Nobody will be happy if you have 100 files at once that you want to merge in. It's better to merge fewer files more regularly. And if you do that to the maximum, to the extreme, you do continuous integration. Today it's called trunk-based development, but that means every little change you do, you commit directly to the main branch. So it gets integrated completely. The same idea is behind continuous deployment, where you want obviously a lot quick feedback, so you deploy every little increase in your main branch. The same idea is with pair programming. Reviewing is good. Obviously, if you do it to the extreme, you have someone watching you and giving you guidance while you program, which is in essence pair programming. And the same idea is with test-driven development. Testing is good, we should do it all the time, and to force us to do it a lot, force is maybe the wrong word, but to do it a lot, you do it to the extreme, where you test everything even before you write the code. However, Ken Beck, who popularized test-driven development, says that he didn't create it, that he didn't invent it, he just rediscovered it. Actually, the first mention of a similar technique, or at least the same technique in spirit, was done by the science committee from NATO 1968. And I want to highlight that because there was 30 to 35 years before the Agile Manifesto, where they're saying that the best way to develop software is to interleave it with design and testing, which is the same idea as test-driven development. So let's have a look at test-driven development. In essence, test-driven development is very simple. This slide is all you need. This is the very essence of test-driven development. You have 3 stages. You start with the red stage, then the green stage, and then you refactor. So it's often referred to red, green, refactor. When you're in the red stage, that means you are writing a test. So it's a test-first approach. You write test before you write software. A lot of people then think, okay, but how can I write a test if I don't even have a software? What should I even write? And the idea behind the red stage is that you want to specify a behavior. You want to specify how should the code look like if I could do what I want to do. Let's imagine we have a system where we want to introduce the concept of users. We didn't have users before, but now we want to have them. So what we would do in the red stage is we specifying that behavior and say, given we have an empty system, when we add a user, then we will have a user. That's our test, and we write that in code. Then we have finished our red stage. Then we go into the green stage. Well, the process of getting to the green stage is implementing it. And you want to implement the behavior. It can be quick and dirty. It doesn't really matter. You don't need to do anything, you just focus on writing the code. That's the essence of what you're doing. And at some point you implemented the behavior, you understand the problem enough to have solved it. And now all tests are passing and you move on to the third stage, the refactoring. As I already mentioned, this is a very crucial stage. A lot of people ignore that. And at this stage, you clean up the code. Now all the messes you did while implementing, now you clean up. Now you make a nice design, you tidy up. Everything you think is necessary to make the code good, you do in that stage. When you practice test-driven development for a while, you experience a really interesting thing. I personally find it fascinating that your brain compartmentalizes. When you are in the red stage, when you specify the problem, your brain switches to a mode where you just focus on the problem. You're just thinking about, do I know everything about the problem? Can I specify the problem? Do I need to go back to the product owner to ask him about how it should work? And when you have enough information, you are able to write the test. When you can't write the test, this is usually a sign that you need to talk to someone what the feature actually should be doing, how you can specify it. In the green stage, your brain goes to a place where you're just a code monkey. You just implement it, you copy stuff, you just want the problem to be solved. And that gives you a little endorphin kick. First, you have the first endorphin kick is when you specified the problem. It feels like, yes, I specified the problem. Okay, let's move on. And then when you finish the green stage, you have that again. It's like, yes, I implemented it. The test is green, it passes, yes. And then at the final stage, when you refactor, that's when you clean up, as I mentioned before, and your brain switches to this architect mode or microarchitecture mode, if you want to call it that way, where you just look at the, I have code duplication here. Is that good naming? I'm not entirely sure. Well, maybe we should change the structure here. This is really ugly. There's a code smell. Let's do this. And that's all you're doing. And you can do that safely because you have the tests that tell you everything is fine. You don't need to worry. And when you have done the refactoring, that's the biggest endorphin kick of them all, because now I have really nice code as well. And that's why I like test-driven development. However, a lot of people know those 3 rules. You write the test, you implement it, and then you refactor. A lot of people ignore the refactoring bit. Then obviously there are people who misunderstand the concepts. So to avoid people making one test and writing 100 lines of code of implementation, Uncle Bob or Robert C. Martin came up with the 3 laws of test-driven development. The 3 laws should give you guidance of how you should do test-driven development. The very first law of TDD says you only write production code to make a failing test pass. That ensures that you have a test-first approach. right? You should write the test first. That ensures that the software is testable and you have a nice user interface and you have nice usability. The second rule or the second law says don't write more test code than is sufficient to fail. So if you have test code, you just write as much until the first test fails. And a compiling error also counts as failing. This ensures that you have a very small test in the first place, the smallest test you can have. And then the third law is don't write more production code than is sufficient to pass a failing test. That means you write as little implementation as possible. You have small implementation to that small test. And that locks you into an incredibly fast cycle of okay, I write a little test, I write a little implementation, I refactor a little, I write a little test, I write a little implementation, I refactor again, and so on and so on. And this cycle can be really fast, like 30 seconds, like a minute, maybe 5 minutes if it's complicated, but it's usually very quick. So to illustrate what I mean with it, I prepared a little exercise which we're having a look at right now. We have here a CMake project that I already prepared for this exercise. It's based on one of my empty repository projects where I just download them, and test framework, the CMake files have all been pre-configured, and I will share the link to the repository of this exercise in the video description. Let's get started. I'm using an exercise that is original from Ward Cunningham that also Ken Beck used in his book about test-driven development. It's quite a simple but yet complex enough example to show some benefits of test-driven development. And the example is as follows. Let's assume we're having an application that trades something, a fintech application. We want to trade stocks. So far, we were only trading stocks in euros or US dollars, and therefore we don't have a notion of money and currency. And we want to be able to trade stuff from other continents like Euro stocks or US ETFs or Chinese bonds, whatever. We want to trade now things that are no longer in one currency. And that's what the exercise is about. We want to create the notion of money, of a currency. Before we do that, let me just quickly explain what you see in front of you. We have here a Google Test setup. Google Test is a framework for C++ to test. It's a very popular framework, and it looks more or less like this. You have a class that gives you more or less the group of tests, and that you add in each of the test functions. So you can, do fixtures, have common parameters, have common objects that you can use. This here is a test where you have the test group or test class is a money test, and the test function is called test suite should work. And all we want to test here is that the test suite works. I have an assert, and I'm asserting that the assert should be false. However, I used a true to false a failure. Here is a custom text that just tells what's happening. So if we run the test fails. It says, oh, I expected false, but it's actually true. And here's the custom message that you can add. So if we change that to false, it should work. Yes, and the test passes. You see here on the left-hand side, the green hooks. You can also remove that if you don't want to see the passing test. When we get more tests, this is more useful. And if we do that again, it will fail again. Just, to see that you look down there, here's a little X that says that the test is failing now. So we know that test framework works. So before we start, I want to give you a pattern that is used in tests, and that is usually you have 3 steps. You have a range that specifies the system, the precondition, how should the system look like before you do whatever you want to test. Then you act. You do actually the thing that you want to test, like creating a euro or storing the euro in a debit account, whatever. And then you assert that the system is now in a state that it should be. For instance, I added 5 euros to my bank account. Now there should be 5 euros more in my bank account. You assert that. A very common alternative to arrange, act, and assert is given when then. It comes from behavior-driven development. I personally prefer given when then. It's more English, or it's less awkward English, because you can say given that the system doesn't have any users in it, when we add a user, then there should be this one user in the system. And that's basically always what you do. So let's get rid of this cluttering and let's start writing our first test, right? We need to start somewhere. What is the most obvious way how to start somewhere? Let's say we traded so far in euros. So I want to be able to specify that how much 5 euros are. So as a result, I just create an object. And remember the second law of test-driven development, you never write more code necessary to make the test fail. This test is failing. Why? Because if I compile this now, it won't compile because there's no class euro, so this test doesn't know what to do, it doesn't compile, so that's my first failure. You see, I hardly wrote one line and I already need to write some application code. So let's add this. I've already prepared a money HPP and a money CPP file, so we don't know the euro class, so let's add a euro class. It still won't compile because I have now a class, but I have a constructor that with an argument. So I still need to add a constructor. You will probably say, I just added a function that doesn't do anything with its parameter. That's a smelly code smell. Yes, that is true, but so far we only have a test that lets me specify that a euro can be created with a value. I'm not doing anything with the value, so there's no reason for me to save this value in memory. So I just do what is necessary to implement what's needed by the tests. I don't do more because why should I? I'm not wasting resources. Now I implemented it and the test passes, so I can actually continue writing my test. Let's say when we create 5 euros, I want to be able to assert equal that 5.value is 5. Again, we will have the same issue as before. It won't compile because that function doesn't exist yet. So what can I do? I just create the member function here that returns an integer for now at least. And we still need to implement this function, otherwise the compiler would complain. It returns an integer value, so let's return 5. Now you were saying, why are you returning constant here? As before, I'm not writing any more code than is necessary to pass the test, which is the third law of test-driven development. Let's try if that works now. My IDE did something. And the test passes and we're now in the refactoring stage. In the refactoring stage, we can do anything that we want, that we think is good for the code, that doesn't break existing tests. There are now 2 philosophies that we can follow. The first one would be there's some test coupling that we want to remove, or we're saying, no, we want to generalize it with more tests. I explain in a second what that means. When we look at the test, we see here we have 5 euros and the value 5 should be returned 5. So we have here 2 magic numbers, 5. We could replace it with a constant, but it's fine. It is not really necessary to change it. It's literally just 2 lines of code. It's not worth the effort. Other people might think it is, but for me right now, it's not worth the effort. However, we have some test coupling here because we have here a constant 5 and here a constant 5. That means we coupled our test to the implementation of the value function. We know that if we change the implementation of value, this breaks potentially our test. And to remove this, we could now refactor it to remove it out. That is one option. That's the philosophy that Kent Beck follows. He implements obvious implementation straight away. He sees test-driven development as a dial. You know, if I'm confident and I'm sure that this implementation is so obvious, I do it straight away. But when something breaks and my confidence shrinks down, then I start doing really little steps and see what is happening. That is one way to go. However, that has the disadvantage that you can end up with a test suite that might not cover all branches and everything. On the other hand, there's a different philosophy of Robert C. Martin, for instance, who introduced the 3 laws of test-driven development that suggest a very strict and very small step-sized iterations. That means, okay, we iterated now our tests and implementation. We could refactor that, or we introduce a second test like this. We introduce a second test with 7 in there. This is called triangulation. So you're getting to the real result by adding more and more examples. I still need to change the name. As you can see, I have a bit of an unconventional naming. A lot of C++ programmers do camel case, which is fine, whatever you prefer. I like the readability of snake case here, so that's why I use snake case for my test name, just as a side note. We now triangulating by adding a second test with a second set of values, different set of values. And now this new test will fail, right? We're returning always 5, but we need a 7. So now we trying to implement the most obvious thing, which is the least amount of code to make this test pass. What's the least amount of code? I would say the least amount of code is actually the real implementation by introducing a member to the class that contains the amount. Yes, and now both tests pass and we're in the refactoring stage. As you can see, we use the triangulation to reach the real implementation, the implementation we knew from the start we wanted to have. Some people find that very frustrating in the beginning when doing test-driven development and when doing strict test-driven development because they feel restricted by this. They are not used of doing those very little steps. However, it has the advantage that your code is just enough code to make everything pass. It's less likely to have an over-engineered and bloated solution. Anyway, we're in the refactoring stage, so we can clean up a little. The first suggestion that my IDE does is, oh, you're returning the value, so you're not doing anything with the value, so return a also return the value if the object is const. So it added a const here, which is nice. It also will tell me that I should probably use explicit because we have an explicit constructor that does that. It also suggests that I could add a constant here, but I find that a bit silly. This is already a copied integer, so there's really no reason to make it const. But if you have a different opinion, please feel free to add a const here. However, here we have a member function, and it also will suggest that we should add a no discard. So that means if we call a function value, you shouldn't be able to ignore the return value. That means you need to do something with it, otherwise you get an error message. Okay, so that looks decent. The code looks like probably like the code guidelines say. So let's run the test again to see if we broke anything. Mostly if we're automated things, so it should be all fine. There is another issue that I'm seeing here is, first of all, we use 5 and 5 here, which is bad. So this is obviously 7. Now it's a copy-paste error, not 7 with double E. It's a copy-paste error, so we're just replacing this. Run it again, and you see that I'm trying to separate refactorings on which side I'm doing them. I either refactor the production code or I either refactor the tests. I very rarely refactor both at the same time because there's a higher chance you're introducing an error. The next step is something I want to show with Google Tests, which some people might not be aware of, but I want to show parameterized tests. We have here duplicated code. Here, €5, value is 5, and here we do exactly the same. The only thing that changes is 7. So we could do a parameterized test that just gives in a value and checks if the value is actually used. How do we do that? The first thing we need to do is we need to create a new class for this parameterized test, because they will need a testing interface. So we use class. How should I call that? With parameter interface. And we have one parameter that is an integer, because we have here the value 5. That should be an integer, and that's our parameter. Now we're writing the generalized parameter test. For that, we copy this. We have here P. We change the value for value test. And then we say N. And here we use, first of all, we use the macro test P for parameterized test. And then we get an integer. Actually, we can say auto, right? So we're creating, we're getting the parameter, add the integer to euros, creating a euro object, and then check if the value of that object is actually the value we're expecting, right? So that's fine. Now we need to instantiating it by and now we can run it. And now you can say we have here 2 test cases, 5 and 7. And it's now very easy to test edge cases. For instance, we want to test, does 1 work? Does 0 work? Does, I don't know, max integer work? There are plenty of opportunities that you can test. And they all seem to work, and we only need to add a single line, and you see an additional test case here. And because we're covering now those test cases, we can get rid of those because they're redundant. They do exactly the same. So we can get rid of this. Okay. That seems all good. Now what do I want to say? We could improve this. We could further refactor it. We could, for instance, say we skipping this explicit variable and we do this. That makes a much neater code. Yeah, still works, and I like it. What is the IDE? Add constant, fine. We test it, still everything works. I don't know, let's start with saying that we can say that 2 euros are equal. So we created a new function, 2 equal amounts of euros should be the same. Okay, so we are asserting. I like to alter the numbers and use as many different numbers than possible. So it makes it less likely they cause some problems. So let's run this. It will probably fail because we don't have a comparison operator here. It tells us comparison operator is missing. Fine, let's add a comparison operator. That is, we need to write the simplest solution to make that test pass. I could now start implementing the operator straight away and say, okay, it always returns true, and then we find test cases where it wouldn't return true, and then we had the real function. However, Robert pointed out during the presentation that the most obvious and straightforward thing is to do just a default comparison. That is true. So I just implemented it, so the test passes now. And, oh, that's the wrong test. Here's the test. 2 equal amounts of euros should be the same. We can test that 2 different amounts of euros should not be the same. So if we take 11 and 99, then they should not be equal. That means there's an assert NE for not equal, and let's run it. Obviously, we didn't see the test fail, so there is a chance that there's something wrong with the test. In this case, it's so straightforward, it's fine. So now we are able to compare 2 euro objects. Okay, let's move on. We have a euro object where we can now specify, okay, we now have a notion of €1. We can compare if they are the same. We can not do anything else. We could make an add function, but let's tackle the add a bit later. One of our main goals was to be able to specify different currencies and have a representation in our software that specifies US dollars and euros. So we want to create a test here. US dollar can be defined. This is a very awful test name, but I can always change it later in the refactoring stage. So let's just go there and say, okay, we want to be able to specify US dollars. This fails, as you can also see from the red highlighting, because we don't have a US dollar. We finished the test. Now we need to do an implementation that satisfies this. Now I do something really ugly, and now you will cringe and say, what the hell are you doing? Now we have a dollar, but we still don't have a constructor. So let's just remove this. And now we have also a constructor that does everything, and the test passes. I can now create a dollar. I can do the same test as before. I can say, okay, I have a US amount of 3 and the amount should be 3. I could parameterize it, but it's not necessary right now. So a US dollar can be created. Now the name is wrong. So, okay, so the test passes and we're now in the refactoring stage and we see this. We're saying that each US dollar is also a euro. That is a code smell because a US dollar has nothing to do with a euro except that it is a currency. So we should change that. Now we could change it in various ways. How I would change it is in the following. I basically create a class money that does this. Do this. Right? Yes, of course. Now let's run it. And all tests pass. Okay. And now we can see, okay, euro is a money, US dollar is a money. That seems reasonable. I'm not entirely convinced that we need a class for each, but let's stick with it. For right now, this is the easiest solution that we can think of. Okay, now let's think ahead. What do we need? We have a euro and a US dollar. We can compare a euro with euro. We can compare a dollar with dollar, right? So let's parameterize this comparison function so we will have a easier time. So because we'll have now some more test cases, comparison test. So we have a comparison test with a parameterized interface, and the parameters are of type comparison money test parameters. Okay, now we have this function and say that's what we want here. Comparison test. We want to compare left-hand side with right-hand side and see if the result is true. And then we can add this test. And we can add this test with the parameters. Okay, then we can add, I don't know, what did we add? We said okay, and now we can also add a US dollar. US dollar, 1 US dollar and 9 US dollar should be false. 97 should, and minus 97 should be true. What we don't want is that a US dollar is equal to a euro. So if we write now and US dollar, and we, let's say, have 4 euros, and 4 US dollar should not be the same. And this will obviously be false because we don't have a notion of currency yet. Okay, so this is not the same. So we need some sort of value there. Well, the most straightforward thing is that we take a string and we initializing it by currency and add here a second value. So that should be fine. But now we have a problem that stuff won't compile. You see already the red stuff, don't even need to run it. But yeah, it won't compile because the constructor needs 2 parameters and we only have 1. So what are we doing? We now have a public explicit constructor for the euro. What the hell? Right, we clean up in a minute. Okay, so let's see if that works now. So now it works. So we now be able to distinguish euros from dollars. Let's clean up a little because we've seen we have now those magic strings. Let's create a constant header file and we call it currency. What I like is enum classes. Enum classes, I like them. They are straightforward, they make sense. Makes it easier to scale if we have it all in one place. So what we're doing here now is we're using this here and use a currency. And it still works. Yippee. Okay, we are still in the refactoring phase and there are still things I don't like. I don't like to have those additional classes. Why? We only use a constructor. It would be much easier if we don't have the different classes but use a factory. We just have a factory that just gives us euros back or US dollars back and initialize our money object accordingly. So all I'm doing here is I'm trying to create a factory method. I just create a factory method that just creates euros, so that return money, and the same here with the US dollars. And now we want to get rid of those euros. So we could do 1 euro, and we want to do the same for US dollars. And now let's run the test. I have now builder functions that just build the currency out of there, so I don't really need those extra classes. Bye-bye. So far, so good. We have a couple more things that my ID tells me. It wants a constant currency and a constant integer. I agree to the currency because you don't know what the background is. It could be a large object or it could be just an enum class. It's an enum class, so it technically is not necessary, but I think it's good practice. For a primary data type like an integer, again, I don't feel like it's worth doing it. So let's move on. We have now a motion of euros and US dollars. We know that 1 US dollar is not a euro, and now we want to start converting. How should we do that? The nicest thing would be if we have a money object. That would be neat, wouldn't it be? Because I could just say I want it as US dollars. I create 5 euros and I want them as US dollars, and then the conversion happens automatically. This usually works if you have a fixed conversion rate, but as soon as you have daily rates or hourly or minute rates, you have an issue because you need to get the real value from somewhere, and that's usually an object. So you end up having a singleton in the background. If you have a singleton, you would need to mock that. That's cumbersome, so I would rather have it explicit, that you have a foreign exchange object and a desired currency. But then as wouldn't work as well, then I would make evaluate. Evaluate those €5 on that foreign exchange to US dollars. That kind of works. An alternative would be also fx.con. We are in an exchange, so exchange 5, evaluate, and then we can exchange 5 into a currency. Both are fairly explicit and easy to test, and we would have a problem with the previous one, because this one, as I mentioned before, would probably make you implement a singleton, and that's not easy to test. As I said, we would need a macro, we would need to play with the linker, that the fake object is linked to this. Is not nice. So more explicit is better, like this. We have an evaluate with a foreign exchange to this, or we go the opposite way and have a foreign exchange where we exchange money into currency. Personally, because it's more like the real world, I would prefer this. Okay, we have a foreign exchange. We add rates from, I don't know, currency, euro to do that. And then we assert that the result this is what I'm thinking. I want to create something like a foreign exchange. I add a rate to it, and then I exchange the euros into US dollars. Oh, the name is wrong, but we can change that later. And that's the structure I want to do, because I think that's the most straightforward and most obvious. I think the most usable, but it's a matter of opinion and experience, whatever you value and what you learn to value. And I want to have noticed that, yes, I didn't stop here at foreign exchange, the minimal step that I could have done, because I wanted to present here what I wanted to do before I'm actually doing it, so that you can follow me better. Okay? And let's implement this then. Create new, we have a new C++ class, and we net that. My CMake file sometimes makes some issues. I have to have a look how to fix this. No, it doesn't compile. Obviously, it doesn't compile. But now it's not a CMake problem. Now it's just a me problem. Okay, now we have this and this, and now you can expect what we're already doing. We're returning a money object. Oh, right, $3. But you notice that we have a really ugly thing here, so let's fix that first, because I want to see something better. Let's implement a formatter. Let's implement a standard OStream operator. So we want to have an output of our money object. Let's do this. ToString, I serialize it. Yes, that's what I like to do. We have now an issue that we still need a formatting clause for the currency. I'd already prepared this because it's a bit boilerplate and cumbersome. And basically say if it's a euro, add a euro symbol, a US dollar symbol, and if it's something else, a question mark. And then just put it out like a string, like you put a string out. Again, you can have a look at it later. And then this gets obviously then applied here and returned into our output string. What are you complaining at a return statement? out. Okay. And that's basically it. We have here a no discard, so we need to do something with the return value, which we're doing. And let's see if it got any better. Yes, we can see now $2 and $3. Nice. Note that I'm not writing a specific tests for this, because first of all, I'm verifying this, and second of all, it has nothing to do with our production code. It's just for debugging. And for debugging, I don't need to write a test for this. It's a matter of measure if you want to do that too or not, but I personally don't think that formatting strings and stuff, unless it is important for your product, I don't think it's necessary to have tests for this. But philosophy. Okay, so we're getting $2, but we should get $3, and it's right. We returned the wrong value. So let's do this. And our exchange already works. Euro can be converted into US dollars. Okay, let's run it again to see if something changed. Why are you complaining? Static. No, I don't want to make it static yet. Okay. Okay, let me just quickly parameterize this function so we can easier replicate conversion things. Okay, now I created the test, the parameterized test. We have here conversion test parameters where we have original money, we have the desired currency, and the expected money with the expected currency. We have here the test definition where we're saying we first create a foreign exchange, we add an exchange rate, and based on the parameters, we exchange the original to the desired currency, and then it must be equal to the expected, right? And I use the same example as before and run it. It's wrong. Yes, because I forgot to, as before, the 3. And now it fits, so I can delete this thing. Okay, let's make it equal again. Before I continue, I find this really ugly, that I have to write this, create euros. So let me change that slightly. First of all, why should my money know about the different currencies? It should be part of the foreign exchange. It's a bit ugly, so let me move over those building functions over to the foreign exchange. Okay, I now moved over the create euros and create dollar functions to the foreign exchange. I also can't create money, so let's just rename that and run it again, and it should be all done. Yeah, still works. And I still don't like it. Look how verbose this is. So what I want to change or refactor is I want to have a literal. So what do I want? I want basically a literal operator, a user-defined literal operator, euro, and that is a unsigned long. And we do the same here for the US dollars. And now we just put the definitions here. Dollars, right, with an amount. And that makes it much nicer code. So it still complains about that it narrows the thing down. So what we do is cast. Now this is a little bit more cumbersome. Okay, so what did I do now? I replaced those long foreign exchange get dollars. 9 euros, 9 euros should be equal. 99 euros, 11 euros should be false. And if it's a minus, I still need to use my static function. Okay, but it makes it so much readable, more readable, much nicer. Oh, yes, something is wrong. Which one is that? The fourth one in my test 2 amounts are the same. Ah, yes, true. I use dollars in both cases, but only this line actually showed me that I made a mistake. Good, that's exactly what I wanted. Perfect, now it works. Okay, let's go back to the hand. We have now 5 euros. We want to convert it to US dollars, and it is 3 US dollars in the end. Let's do another example. 4 euros, 2 euros should be 4 euros. And this will fail. This will fail because so far we have a fixed value here. Yes, 3 US dollars is not equal to 4 euros. We can say, okay, if money.currency is equal to desired currency, then return money, right? But we don't have a currency function yet. Returns a currency. Let's add an implementation. And we still make a no discard. Yes, and a no discard. So if the money currency is equal to the desired currency, then don't do anything. Just give them the money back. Let's run it again. That seems about right. Okay, we have 2 options again. We have this case with the 3 US dollars. We obviously are coupled here. We could triangulate again like before, or we could just say this is test coupling, we remove it. I like triangulation, so let's say 4 euros into US dollars are 6 US dollars. Okay. Now we need to say returning money value times 2 desired currency, right? That's our times 1.5. Okay, this gets a little bit more complicated. So we basically saying we have now a double, and then we just convert it, static cast integer. Okay. We still have the code coupling here of the 1.5. And to fix this, I just go now the other way around. I go from, let's say, 9 US dollars to euros. That should be 6, right? Okay, this is now getting more difficult. There are multiple ways how to do that. I could now just, in a silly way, say if the desired currency is euros, then do this. If the desired currency is US dollars, do the other one. Then we would need to add a third currency, like British pounds, and then we would generalize it. For the sake of this presentation, I will just skip a little ahead and says, okay, let's do a proper implementation, and I would do this. We have a rate, money currency to desired currency, doesn't work yet, and it says from and to, Let's keep it simple, and that is, no, let's keep it from and to. Let's keep those all nice and similar. I have two choices. I could now have this failing test and write the test for add rate, but we testing this function as well, so we don't need to implement it. So we can say I created here field or member, which is a map that maps to currency, the from currency and the to currency to a float. That's my storage, how I want to store rates. If there's a better way, there might be better ways, you know, it's all good. So the first thing I'm doing in my map, I'm trying to find the key, which is two currencies from and to, okay? And then if we're getting an iterator back, so if it didn't find it, then we throw an error for now. I just throw a string, but obviously we would do better error handling here. Okay, and we return the rate here. And we got the rate. We need obviously to create a yes. And it still doesn't comply because we're throwing an issue in the test body, because here we want to convert from US dollar to euros and we don't have that rate added. So what we can do is we add at the same time the opposite direction, to and from, with the inverse rate, 1 divided by rate. Let's have a look. And now it worked. Nice. Let's refactor a little bit because it got a little ugly. We have here an if statement that we could replace. If from equal to turn 1.0, right? Then we no longer need this. We get a rate. Let's check if it still works. Yes, it still works. Again, in real application, we would probably want to test this, and we would probably want to throw a proper error or to do the error handling somehow differently. Good, now we can convert between those two. That's all great. The foreign currency looks fine. We have an exchange function, a get dollar. We have the literal values here. All sounds reasonable. Okay, what now? Now we have to do what we actually wanted to do. We want to have a portfolio where we have, I don't know, Chinese bonds with European stocks and, I don't know, American ETFs. And we want to have them all in our portfolio, and we want to know how much our portfolio is worth. So what we need to do is we need to add the values of different currencies. Let's write a test for this to say. So we have, let's just take this. I will change the name. It's an awful name. I will change the name to something better. We want to do something like 5 US dollars plus 3 euros. We want to evaluate that as, I don't know, British pounds or US dollars or euros. This would look really nice, but again, we don't have much information here. We can't specify the foreign exchange that does the conversion, so we probably have a singleton somewhere in the background that we need to get rid of if we want to test that. We don't know the desired currency, what should be the result, so we could do something else. We could, for instance, say we have the sum of 5 euros and 3 euros, and then we want to evaluate them into euros, let's say. But obviously this would also have a background dependency on the foreign exchange, so we would probably want to have something like this. It's similar to what I proposed before, you know, that where we evaluate money into euros in favor of the foreign exchange function, I discarded that idea, but maybe it wasn't a bad idea after all. Let's do this. $6 and we want to evaluate that in euros, and $6 or 4 euros plus 3 euros would be then 7 euros, right? So we still need the foreign exchange. Let's use the same as we did before here. So let's try this. We don't have a sum object yet. There might be that we want a sum and subtraction and stuff as well, maybe multiplication. So I just call it expression for now. Our CMake file makes problems as usual. So let's just quickly open it and fix it. We want to have our production code in the production code side. Okay, so let's have a class sum, not small sum. And okay, now we have sum. We still need a constructor. Yeah, let's just do this. And we need an evaluate function. And we call that currency, desired currency. Okay, so far so good. Now our test should be compiling. I found the issue. I forgot the return value. How silly of me. Okay. We're now getting the wrong value back. Obviously, we're returning just a fixed value here. So what are we doing? We're sending back the right value, and now it passes. As you can imagine, this could be a lot of combinations of US dollars and euros until we reach a good solution. So I will quickly refactor this test into a parameterized test. So I created this little parameterized test where we have the parameters left hand side, so the first money plus the second money of a different currency, with the desired currency as an output and the expected value that we should have. I created a foreign exchange with the exchange rate, and then I create the sum of left-hand side and right-hand side and evaluate the desired currency, and then I check that's the expected value. So let's run this. Yes, no, fair enough. Fair enough, and now it works. So we can delete this one and can easier write test cases. So if we want to have, for instance, $6 plus $6 should be 8 euros, right? That obviously the second test will fail. So how could we do that? Let's have a look here. We have a sum with left-hand side and right-hand side. fx dot exchange left hand side in desired currency, right? That is money 1. Oh, actually I can write left hand side, and we have right hand side is, and then we can just create desired currency. We obviously need to create those 2 fields. Where do we have the foreign exchange? We never change anything when we add the rate. We don't do anything, so we could make this end as constant, and we could create that function as constant, and that would solve our issues. Right, let's try this again. Okay. It's fine. Now that works, and it seems to work fine. Now let's clean up a little. I've seen we did some message. I did some message stuff here. So let's add the no discard, constant, constant, constant. This is static, static. That should be fine. Double. Let's check here. This is name to X. I just made sure that those are similarly called. From 2 seems fine. We have here different name. So let's use the proper name in the header file. Add const, fine. Whatever. Let's run it again. We cleaned up a little here. We cleaned up here. Here we need a little bit more love. We can add a constant. That is good. Add constant, that's fine. And in the header file, where's it? Expression header file. Is not much to do except a no discard, and we're putting those 2 private. We do proper encapsulation. So far so good. That all seems reasonable, you know. Okay, what we can see here is that we already can convert between the different currencies and add different currencies together. And what this design also allows is, for instance, a test that looks like, let me have a second. We can say that the sum of sums can be evaluated. For instance, let's try something like, so if we have a test that says that the sum of 5 and 2 euros, as well as $5 and $2 in euros. Oh, I forgot the exchange. 1 second. Okay, to make this test work, I needed to make the unique pointer, share pointer, so the copy constructor was possible. Anyway, that is just C++ sugar for making it work. If that's a good choice or not, that exceeds the content of this talk. But if we have a look back at the test, we can see that through this structure, that the summation is a form of expression. We can have the summation of 2 money objects and sum them together with other summation results. The test's failing because I didn't do the maths. 5 euros and 2 euros are 7 euros. 5 US dollars and 2 US dollars, obviously, are also 7 US dollars. Times 1.5. Well, the test already calculated it to 11, which seems about right. And you can see that the test works. You can see that we did multiple things here with test-driven development. We started out with a very simple test where we just created a simple Euro object. And by having more and more tests, we were able to not just have a Euro object or the US dollar object. We abstracted it even further and were able to create a money class that generically contains the value and currency. We were able to clean up properly. We were able to make it tidy. It's very concise. And if you wouldn't have used test-driven development, you would have begun with a Euro class and a US dollar class, a British pound class. And this is an effect that I see very often in test-driven development, that actually it impacts the architecture a lot. Because I have a lot of iterations, and with each iteration I clean up, I look at code smells and I see stuff that is ugly that I don't like. So I fix it straight away. Because they are small iterations, the cleanups are never long or rarely take longer unless there's another issue. And every time you do a cleanup, you can be sure that you have broken anything because, all tests are still passing. Anyway, after creating euros and US dollars, we were able to verify that a US dollar is not a euro, which brought us to the abstraction of currency, of what types of currency we have. And then in the next step, we were able to convert between euros and US dollars. For instance, here we were able to convert between the different currencies. We introduced a foreign exchange concept, that there is something that exchanges currency with a particular rate, like here. And in the end, we created a concept how to add different values together. Obviously, because this is a demo, I wasn't doing all the things that I would normally do in production software. For instance, when we are adding euros together, I would probably also check the boundaries and those extreme values. Does it work when I add two maximum values of a currency? I haven't considered the decimals of a euro or of a dollar, cents. I usually would have looked at exchange uncertainty, we multiplying with doubles, so there could be conversion mistakes, so I would have covered these. But those are all things that you think about in the testing phase. After you're done with the test, you have a look and you see, how could this break? Your mindset is changing. You're no longer thinking of, I need to do the next thing. You're thinking like, okay, how does that work? Can it break somehow? What happens if I do this and this? Does it still work? So it puts you more in a tester position than in a code monkey position. Similarly, you look a lot at the architecture, particularly in the refactoring stage. You look like, does it fit together? Is there a form of abstraction that I'm missing? Are there too many abstractions? For instance, we introduced the currency. It's just a simple enum class and a code formatter, which makes our life very easy just by being able to compare different values. Generally, there's far more to say about testing and test-driven development that I can cover in this, not so short talk anymore. And there's a lot more to learn. There is, for instance, the two different schools of test-driven development, the London school and the Chicago school. They approach things differently, but if you apply test-driven development like I've showed you here, it's a good start. Try to do the short interaction. Try to use, particularly in the beginning, triangulation instead of skipping steps, because every time you skip steps, there's a danger that you miss something, or that the design in the end is not as optimal as it could be. But in the end, test-driven development comes a lot down to experience and knowledge. I surely went down a different path than someone else would do. if you don't have the experience in software design yet, you might end up with a very coupled system. But I will talk about that later in this talk. For now, let's go back to the presentation. In the exercise, you just could see how I implemented stuff. You could see what choices I did and how those choices brought me to the result that you saw in the end. I'm not saying this was the only way to do it. That was just my approach to the issue. So I hope you could see a few benefits from what I was doing. First, the code will be testable. That's completely natural. You writing the test first, so you specifying the user behavior. Then we have also the case that in many cases the code can become more modular and less coupled. It is not a guarantee that it will be more modular or less coupled, but there's a trend towards modularity and less coupling. Test-driven development gives you quick feedback on changing behavior, that you just introduced a bug and some tests are breaking. And the nice thing is you're locked in this really quick cycle. So whenever you test and suddenly another test breaks somewhere else, you immediately remember what you were doing just a minute ago. When you develop without test-driven development, it happens that sometimes you test a couple of hours later, maybe a day later, maybe it's a couple of days later, and you need to remember what you were doing. With test-driven development, you don't need to do that. You know exactly what you did just a minute ago because you just did it a minute ago. So it's really quick behavior on failing tests because you exactly know what you just did. You just check why the test is breaking, and then you typically realize, oh, that's what I did wrong. Whoopsie, let's do it differently. But it also gives you feedback on your design. That feedback usually results in, this test is difficult to write. Not because I don't know the specification, it just becomes more cumbersome to write it. This is awkward, I need to initialize too much, this function has too many dependencies. And that's feedback from the tests or from writing the tests that point towards design flaws. And that is a really good thing with test-driven development. It helps me a lot to design better software, more modular and less coupled software because of that feedback. Naturally, because you write so many tests and for every little thing you write a different testing behavior, you have a really high test coverage. And that obviously increases your confidence, and because you have higher confidence, you can refactor more. And to be honest, I am a very merciless refactorer. I refactor many things, sometimes upsetting my coworkers. Very rarely, but it did happen before, that I refactored things to 1-2 times and they got upset because we were working at the same thing. Happens. But at least I didn't break anything because the test worked. Those are all amazing things, and I hope I hyped you a little bit to do test-driven development. But when you then go on social media and watch YouTube or Twitch and watch the Primagen, or look on Twitter and read some posts of DHH, and those people really hate TDD. Maybe I'm exaggerating here, but they really don't like it. And I was always wondering, how can that be that I really like TDD? I think it makes me a better developer, and those capable programmers, those experienced programmers, they hate it. They really don't like it, even though for me it was completely transformative. So I have to admit there is an ugly side that TDD can have. I personally would say this happens because you misapply principles of TDD, or you weren't aware of certain issues when you did TDD. Others would say, well, it's obviously a sign that it is broken. In whatever camp you are falling, I want to address some of the ugliness of TDD. I won't be focusing on how to write tests like anti-patterns for test writing. There are plenty of blog posts out there that will cover that topic. I will also link some of them in the description below. And I want to have a look at more the hidden things that make test-driven development difficult. The very first thing that makes test-driven development difficult to use is, of course, your line manager. When you ask your line manager that you want to do test-driven development now, and it's so amazing, you write tests, you write code, you refactor, it's so amazing, it will just improve everything. They're usually very skeptical because all the hearing is you want to do now more things while doing the same work that will take you much longer. You want to write additional tests? We hardly have time now to write tests. I would love if you don't write any tests. That's what I hear when the line manager speaks. What, you want to refactor regularly? No. We do that once every half a year for one day. That should be suffice. This just will take so much longer. That's, again, what I hear when my lines manager speaks. So let's talk about this. Let's talk about the lead time in test-driven development. And the truth is, test-driven development is slower, about 16% slower. This study has shown 60%. That study has shown 6 to 35% slower. And the third study has shown 15 to 35% slower. Those are significant drawbacks because 16%, if you're a team of 6 or 7 people, that's one additional coworker. And the same goes for 35%. If you're 35% slow and you're just 3 people, that's an additional guy you need to keep up with the turnover. But other studies have shown that the number of defects drop drastically. This study has shown that you have 40 to 80% fewer defects. This study has shown that you have 40 and 90% less defects in long-term projects. And that's a very positive thing. I mean, that alone would convince me. But unfortunately, in my experience, most line managers are not convinced by those numbers. In all honesty, the majority of studies on test-driven development are based on students at the uni, which is fine, nothing wrong with it, but it doesn't really reflect a professional software engineer. They usually lack years of experience to properly compare them. Okay, let's say you convinced your line manager you're doing test-driven development, and test-driven development goes well for a while, and you do it and suddenly you're realizing you're getting slower and slower. The quick cycles of 30 seconds, of a minute, or 5 minutes, they're becoming now 5 minutes, 10 minutes, 15 minutes, 20 minutes. You can go for a break while your test suite is running. And suddenly this quick feedback is more like, yeah, I have 2 or 3 times a feedback a day. Or you start running the tests only in a pipeline because it's no longer reasonable to do them all on your PC. That's the next problem. You might experience the tests take too long. And one of the reasons for that is that the testing pyramid that should look like this, that you have a really large number of unit tests on the bottom that go really, really quick, that enable you to have this very fast TDD cycle, you just increase the integration and end-to-end testing disproportionately. And you end up with the inverted testing pyramid. You have almost only end-to-end tests. Let's say you do a web service and you only do API calls to test if the system works. Fundamentally, there's nothing wrong with end-to-end testing. It's important. There are other methods like behavior-driven development or ATDD, which is acceptance test-driven development, that do exactly this. They specify a specific behavior as an end-to-end test on that level, and then you implement it usually inside with TDD. At least that's how I do it. But if you only have end-to-end tests, your test suite will become really slow. The issue we're talking about. You have the advantage that you can freely refactor because you just tested the boundaries of the system, so you can refactor literally anything in the system. But what you're losing is the quick feedback on the design, the quick feedback on the accuracy of the system. And the tests become less precise, because if you say, okay, I want to request a user and this request failed, then you only know somewhere in this software, I cannot no longer fetch a user. What's happening? I'm not sure. Let's need to throw on the debugger, go through step by step and see where the issue is. The disadvantages as well are that the code can still be badly coupled, it can still be spaghetti code, you still have all the ugliness that you had before, but the benefit is, well, as long as the user gets the right output, I don't care. And that is fair enough. In all honesty, the most common reasons for this is that you're working with a legacy system. Doesn't matter if it's a new legacy system or an old legacy system, but generally speaking, it is a system that is not designed for testing, not necessarily, but often not well designed. So what do you do there? The idea is how to solve this is by having still the end-to-end tests. You still keep them, they're still important, but you keeping those tests in place, and then you need to start refactoring a lot and need to separate those things out. You need to decouple things and write unit tests for them. So you can have, again, the quick cycle you want to. This seems silly because you're not producing any value for the customers. You're just doing maintenance. But without this maintenance, you won't be able to have a well-tested suite. So the idea is just to break it down in smaller bits. And now let's think about, okay, you're following my advice, you broke down the system and you're going the opposite direction. You say, okay, I want to test every single class. I want to test every function of every class. And then you will realize, whoops, I end up now constantly maintaining my test suite because no matter what I'm doing, my tests will constantly break when I refactor something. When I do a bug fix, I need to change tests again. So you just told me that when I do test-driven development, I will be able to refactor. So why are the tests constantly breaking? It's annoying. And there are reasons for it. There is, for instance, structural coupling. If we have a look at this diagram, this is not a bad diagram. This is a class diagram of Eclipse Link, which is an ORM model, an open source model from Eclipse. And I'm not showing this to show this is a bad design. It is not. I mean, I don't know. I haven't looked at it in that detail. What I'm showing you is a real world example of a class diagram. And if you test every single one of those classes and every function of those classes, you have really great test coverage and you can precisely tell me when there is an error, which class, which function is the issue. However, it comes with a problem. And when you want to refactor it, you often change the structure of the system. That means that this class diagram will look different. Let's say our company wants to have some advice from an external consultant. Let's call that consultant Klaus. And Klaus really loves type erasure. So he convinces the development team, yes, we could make it much easier and easier to maintain if you use type erasure. Okay, all the developers are now convinced, they love the idea, and they go ahead with it. And the entire tree structure you can see in some bits of the code, they just disappear. And then you end up suddenly with hundreds of tests failing because all those classes are gone. You need to do more maintenance on the tests because you're coupling the tests to the implementation structure of your code. So how can you prevent that? You can prevent that by grouping classes and objects into units, logical units. For instance, if we take the example from before where we wanted to introduce users, we had one logical unit that was user management system. This user management system that might contain other classes in it that you test through behavior indirectly. But however, you still test it because you do test-driven development. That means you only write production code if you have a test for it. So if you wouldn't have a test for that behavior, this other class wouldn't exist, but you no longer know of it. And that's the key. You don't need to know implementation details. Okay, let's say you followed my advice and you're grouping more of those things into units and you create now separate units, and you will realize that some of the units, they will have dependencies that are necessary for some reason. Then you end up mocking all the dependencies. And mocking is an important technique where you can get rid of dependencies for a test. So you can only test something specific. You want to test how to add a user. However, this user management system uses some database in the background. So you can mock this database away so that you only do in-memory thing. You don't need I/O and the tests go really, really quick. This is a reasonable approach. For instance, how you can do that, you can see in this example. This is a Google test example where you have a test, where you have a painter object, and you test whenever you call the draw circle function that at least once the pen down function of turtle is called. This is, as I mentioned, sometimes necessary to remove dependencies. However, now this test knows of the pen down function. It knows about internals of a unit. This is obviously, again, coupling, and mocking can be very dangerous because people tend to overuse mocks and apply mocks to everything. It's like, okay, I have this class and it depends on 2 other things, so let's do 2 mocks there. And again, then you get a little bit of structural coupling and you get of test double coupling, and your test will be brittle because now, again, like any coupling, you refactor it and you will break test. So you should still do mocks when necessary, but really do it consciously and only do mocking when necessary. If you want to know more about mocks and what the difference between those different types are, have a look at this blog post. I will also add it to the description below. I often also see another form of coupling, obviously also not great, is you have a unit, or in this case a class, and we are back to our user management example and want to test that we're adding a user, and then we want to make sure that our system has now exactly 1 user after adding exactly 1 user, right? Makes absolute sense. The test is reasonable. However, the implementation is not great. What you see at the bottom of the test is that we're looking inside of the class and using internal data structure to test if we actually added one. But in test-driven development, you should only use public interfaces and not the internals because of the implementation coupling. Now my test knows that there is a container, which in that case is a vector, is in the background. So whenever we refactor it and deciding, we should really put that in a database, our users, then we are screwed. We need to maintain the tests, rewrite the test, change the test. And whenever you change code, there is a high chance of introducing a new bug. And that's obviously not great. So I wanted to give you a highlight of all the things that a lot of people do, but not aware of that this can have bad consequences. After telling you how amazing test-driven development is, I completely disillusioned you now by telling you how awful it can be. But my message here is that test-driven development can be hard. It requires discipline. It feels very restrictive in the beginning. You need to unlearn habits that you were doing for 10, 20 years if you're a seasoned programmer. Or it needs architectural knowledge, design skill, and practice that new developers usually lack. So it's hard for the seniors and hard for the junior developers. One last advice I want to give you is that please don't learn test-driven development on the job. That's a bad idea. It will go sideways and you will never want to try it again. You need to practice at home first until you feel comfortable with the rhythm, and then you can go to work and apply the things there. Besides all the troubles that tests and test-driven development can do, I still think it is worth it. You will have fewer defects, you will work more agile in smaller steps and cycles. Your focus will shift from implementing and being a code monkey to design, usability, and that's what was so transformative for me. For me, it was very transformative to suddenly have dedicated times to rethink my design, my usability, to have the confidence that I can refactor when necessary, which led me to a more testable and modular code. And in all honesty, I really enjoy test-driven development. And that's why I would like you to apply it as well and do a lot of test-driven development like me. And it will hopefully be more popular in Central Europe at some point. In any case, if you want to try it or not, and I thank you for giving me your time and your attention. Thank you.